All right, let's look at the braking distance problem. All right, so here is the situation. The car is initially traveling at V0 meter per second and then applied brakes. And these brakes gives you a negative 20 meter per square second of deceleration. And it took the car 75 meters to come to a complete stop, right? The question is, how fast was the car going? All right, so let's do that. So what's given, so let's try to identify everything that's given. So you have deceleration, so that's going to be the acceleration. So this is our A of t. So this guy right here is the acceleration, our A of t. Right? And a v0 is of course the same thing as the velocity at time 0. Alright, and here, let's see, it came to a stop, so velocity here is 0. Alright, and at this time, so the distance is 75 meters. So maybe I'll call it x, because it's a horizontal distance. X is 75 meters. Alright, so let's start with acceleration. So we know that the acceleration is A of t. Right, so which is negative 20. Right, so let's take the antiderivative. Right, let's take the antiderivative, find the velocity function, v of t. Right, so which is going to be equal to, so it's an antiderivative of negative 20 with respect to time, which is simply negative 20 t plus some constant, say c1, right? But we have initial conditions, so when v of 0 is going to be equal to, if you plug in 0 for t, so it's going to be just a c1. And this is the same thing as the initial velocity v0, which we are trying to find. So we have this complete formula, which is negative 20t plus velocity v0. All right. Now we can try to find the distance formula, distance function. So I'm going to call it the x of t. All right. X of t is simply an antiderivative of a velocity function. So you have a 20t plus v0 with respect to t. And this is going to give you antiderivative of negative 20t would be negative 10t squared. Antiderivative of v0 is v0t. And then you might have a constant, some c2. I'm going to call it c2. All right. But we know that initially position is going to be 0. Or maybe I should have done that. So here, x of 0 is equal to 0. So if you plug in 0 here, that's 0, then you just get the c2, right? And this happens to be just 0, right? So the position function is really just negative 10t squared plus v0t, right? Then we know that when it came to a stop, velocity is equal to 0. So let's try to see when that happens. So we're going to set the v, going to go here, velocity, which came out to be negative 20 t plus v0. We set that equal to 0, right? Then we can see that if by isolating t, you will have v0 over 20. All right. So which means that at this point the time is v0 over 20. So we know that the v of v0 over 20 is equal to 0, right? So distance wise, we know that the x0 of v0 over 20 should give you 75 meters. All right, so let's solve that equation. So you have x of v0 over 20. So we plug in t equals v0 over 20 here and there. So it's going to be negative 10. And then you have a v0 over 20 squared plus v0 times v0 over 20. Right? So let's simplify that. So this is going to be negative 10 and v0 squared and the 20 squared. I'm going to write it as 20 times 20 so that I can easily cancel. And then plus you would have v0 squared over 20. Alright, then we can cancel 10 and the 20 and the 2 left over. So you would have, let's see, v0 is on top. Right, so it's going to be negative, and 2 times 20 is 40, plus v0 squared over 20. Right, v0 squared over 20 is 2 times v0 squared over 40. So this is going to be simply v0 squared over 40. Right. And then we know that this is supposed to be equal to 75. So we can set that equal to 75. All right, then we can just solve this. So this is going to be, this is going to give you, right, multiply both sides by 40. So we get v0 squared is equal to 75 times 40, which is 3,000. All right, then we would take the square root of both sides. Then the v0 is going to be plus or minus square root of 3,000, which is going to be plus or minus 10 times square root of 30. Right? But in this case, we know that the velocity is going to be positive, so therefore what we are looking for would be 10 times square root of 30 meter per second. Right? So that's the velocity, how fast the car was traveling when they first applied the brakes. Right? That's it. I hope that this was clear.